Hi, good day once again. In this video, we will be learning the fundamentals in trigonometry, specifically in using the circular and trigonometric functions. Because there are two systems that are used. We have the degree measure, and most of the time we are using the radian measure. Let us get to know all of these step by step in this very short video. We know that a circle should have a radius. The distance from the center to the point of the circle. So 1 radian or rad is the measure of a central angle subtended by an arc of a circle that is equal to the radius of the circle. As you can see, look at here. But we know that this is the radius, and this could also be the radius, right? So as you can see, one arc length, example, one arc length is equal to 1 unit, and the radius is also 1 unit, and the other radius is also 1 unit, so they are equal to each other. That is what we call the radian. Okay, and the arc length, you'll be familiarizing this all about the arc length, something to do with the radius. Now, we know that the formula of the circumference of the circle is 2 pi r, where r is the radius of the circle. So if the radius of a circle is 1 rad, the circumference of a circle is like this. But we know the radius and 1 rad is just the same. So that becomes 2 pi rad. But a circle subtends an angle of 360 degrees. We know that it is only up to 360 degrees. Thus, we know, right, the circumference, circumference is the distance that covers the entire circle, right, 360 degrees. We know that this is 360 degrees, right? But we are only going to use the radian measure since this is more commonly used. So how to do that? Let us have a little bit of mathematical manipulation. So let us divide these both sides by 2. Okay, cancel, leaving you with pi rad. Aside 360 divided by 2, that is 180 degree. And since we are only looking for the rad, then divide it by pi on both sides again. So you have cancel, that is only rad is equal to 180 degree over pi. Therefore, the value of any radian or any, let's say, degree, which is equal to 1, is 180 degree over pi. And the pi, we do not know the pi because we know already the pi, which is 3.14. Okay, but yeah, look at this. 1 degree di is equivalent to pi, let's say pi over 180 degree. That is the reciprocal. Later on, we will have concrete examples. This is the example, diba? We are now going to convert angle measures, from degrees to radians. So you're just going to multiply the degree, for example, 40 degree times pi over 180. Then simplify. Then how about from radian to degree? So that is 180 degree over pi. Just a reciprocal, diba? Bali lang. Okay. Example number 1, you have radian measure 5 pi over 3 times, again, 180 degree over r. So take note, if it is radian, then we are going to multiply the reciprocal of it. Diba, pi is in the numerator, so the other pi should be in the denominator, just the reciprocal. So you have 5 pi times 180 degree over 3 pi. Or you can have cross multiplication. Okay, pi times pi, that is cancelled out, leaving you with leaving you with 5. So how about 180 divided by 3, or the GCF of 180 is 3. So 180 divided by 60, that is 60 degree, leaving you with 5 times 60, that is 300 degrees. Now the radian measure is now in degree measure form, right? Very simple. Or to make it very quick, but not all the time it applies, but I guess it applies, yeah. So this is an example for you to have a very quick method, because we all know that if it has pi here and pi in the denominator, you're just going to cancel it out, diba? And then you are just going to multiply 5 times 180, that is, yeah, divided by 3. If this is how it looks like, okay, you can easily substitute 180 in pi and divide it by 3. 5 times 180, that is 900, divided by 3, that is 300 degrees. In the number 2 example, 3 pi, it has no denominator, so still 180 degree over pi. So cross multiplication again, pi over pi cancel out, so that could be 3 times 180, that is 540. Excuse me. And the last example, 7 pi over negative 7 pi over 6. So again, multiply it by 180 degree over pi, cancel both pi's, and leaving you with, oh, hold on, 180 and 6. What is the common factor of these? That is 6, of course. So 6 divided by 6, that is 1. 180 divided by 6, that is 30. So that must be negative 7 times 30. That must be 210. Okay, negative 210, and you do not have a denominator to that. Okay, how about the vice versa? From degree to radian measure, of course, bali na po, no? If you have the numerator degree, and the denominator should be the degree, so that you can easily cross multiply. So you have 225 degree times pi over 180 degree, and of course the method that we use, the GCF. So just divide it by, okay, so that must be the GCF, no? The GCF of this is 225, no? That must be, what should be the GCF of 180? And is this a 30? Hold on, 225 divided by 5. Okay, so the GCF di is 45. Yeah, it makes sense, because 225 divided by 45, that is 5, and then 180 divided by 4, that is 45. Okay, so just find the GCF, because we are not going to use decimals, no? We are going to use fractions, so we need to find the GCF as much as possible. So you have remaining 5 times pi and 4 over 4. Another example, 75 degrees, multiply it by pi over 180 degree. And what do you think is the factor? I guess it should be 15. Correct. 75 divided by 15, that is 5. 180 divided by 15, that must be 12. So you have 5 pi over 12. Just find the GCF. The third one, negative 210 pi. Okay, just multiply pi over 180 degree. That must be the factor of this. The GCF of this is, I guess it's 30. Let me check. 210 divided by 7. Yes, it's 30. So the GCF of these two is 30. 210 divided by negative 210 divided by 30, that's negative 7. And 180 divided by 30, that is how much? That is 6. Okay, so leaving you with the final answer, negative 7 pi over 6. That's it for the converting, let's say, radian measure to degree measure and vice versa. Thank you. Kindly watch the next video for the next lesson.